Hi, my name is Ted Monholland, and we're here working on Project 4 for our Experimental Methods Lab.
Okay. My name is Tulwani, and we are working on Project 4 Experimental Lab.
Okay.
So, let's get started. First things first, we have to measure the RMS voltage on the circuit. These are step-down transformer used to measure the AC voltage.
Okay.
And these are circuits already set up, and yeah, that's it. So we want to measure the RMS voltage, that is the root mean square voltage coming straight from the transformer. So I'm just gonna hook this up here. And turn this on. So from here, that is the multimeter. You can see the voltage here. This voltage here is the cumulative voltage from both the positive and negative terminals. So to get the RMS voltage, you're going to divide this by 2. So that will be like 13. That will be like 13 volts divided by 2. And that will give us like 6.5 volts. So that will be our RMS voltage. So we are going to use RMS voltage to set up this circuit, to calculate the resistance of the resistor, and so that the LED light will not be blown up. Yeah, thank you.
Okay, so now we're on to part 2. We're actually designing the circuit here. So what we have is, we have the 7 volts is going to go one way and then the other. Alternating current means that it goes around this way and then it also goes around this way. So what happens is, these light bulbs only work one way. So when the voltage goes starting from here around this way, the lights are going to turn on. And when it comes around this way, the lights are going to turn off. And the frequency of the AC current is so fast that you can't tell when they turn on and off. You might see a slight flicker, but other than that, it's hard to tell. So this is them on.
Oh, he's flickering.
Okay, you can see a slight flicker of them, so that means that they're on and off half of the time. And so in part 3, we take a couple of the LEDs and we reverse their polarity. And so what should happen is, these ones would be lighting on at the times that these ones are turned off. So it's hard to see right now because they're flickering so fast. But if the frequency were to be turned down, then we would see these ones on and this one off, and then it would switch back and forth. Every few seconds you would see the switch. And so that's all for that part.
Okay, so we are going to show how to convert AC voltage to DC voltage. Okay, so we are going to use a rectifier circuit to do that. But first of all, we are going to show the waveform of an AC voltage in the CRO, the cathode ray oscilloscope. So I'm just going to hook this up here and turn this on. Yeah. So this shows the waveform of the AC voltage before we construct the rectifier circuit. This is the sonic up and down. That is the waveform. You can see that it's still going to the negative, but by the time we rectify it, we are going to have this graph. Let me turn this up. We're going to have this graph here. Like, it's going to pass through this, and it will pass through 4 diodes like this. Like, it comes here. No, the current enters through here like this, and goes this way. Then it passes through this resistance here, and comes this way and comes down. This resistance is going to make it, like, it's going to remove the negative part of it to make it a direct current, giving us this graph. And when it enters here, it can also go this way, like this. So that is the main function of a rectifier. It rectifies an AC voltage to a DC voltage. Then this is the calculation. Like, we are going to show how to calculate everything. Then after calculating, we are going to measure it also. So let's go. Like this is the formula is given by A over T naught. Here is the amplitude and T naught is the current at the beginning. So we are going to integrate from 0 to sin T naught sin 2 pi 60 t dt. So once we calculate this, it's still going to give us the voltage gotten by this graph. That is the rectified graph, and you're also going to this DC voltage measured and calculated, and this will be the RMS voltage measured and calculated. You can see that the voltages are different. I'm sorry. Like the RMS voltage is like half of the DC voltage and all that. Yes. So this is also the formula for the RMS voltage. A squared T naught integral 0 to T naught sin squared 2 pi 60 t dt, all raised to power half. So that is the main thing. You rectify to make the voltage go in one direction, giving us a DC voltage. Sorry, the current also. Yeah, thanks.
Okay, so here we have our final project. We're using a rectifier right here to convert this AC current into DC. So from here to here, this turns into a DC current.
Made up of 4 diodes.
Right, the 4 diodes are what create the rectifier. And so the DC current is going to be from here to here. So we just start right here, and the current's flowing this way through the LEDs around here. So what's going to happen is when we turn it on is the lights should all turn on, and they should no longer flicker because it's DC current coming along through here.
And there's the resistors used.
And we use, the resistors are used to dissipate that last bit of voltage. So, as you can see,
it's no more flickering.
They've stopped flickering, so we've successfully converted AC to DC and powered the 20 LEDs.
Okay.
That's it. Thank you.
Yeah.